who are going to do a fireside chat. They're both experts in security. They both used to be co-workers, and now they're sort of experts within their own region. The first one is Dr. Zulfikar Ramzan. Zulli, as we all know him, is a Chief Technology Officer at RSA. In this role, Zulfikar is responsible for leading the development of the company's technology strategy and will focus on bringing to market the innovations that help RSA's customers take a business-driven approach towards security. Rehan Jalil is a serial entrepreneur. He started up several companies. He sold his first company, Y Chorus, which was eventually sold for a little over $180 million. He was not terribly happy with that outcome, so he went off and started a second company and sold that company within 2 years for over $300 million. Rehan is now, that company then subsequently got acquired by Symantec, and I'm not sure how long he's going to survive there. I don't know when his vesting is over, but we'd love to hear about his next journey as well. So please join me in welcoming Rehan and Zulli. It's going to be a fireside chat, and they're going to each interview each other. Interesting fact, both Zulli and Rehan started up Elastica, which then got acquired by, eventually got acquired by Symantec. So join me in welcoming Rehan and Zulli on the stage.
Your agile machine learning in action right here.
It's like a bring your own chair.
All right, well, first of all, thank you all for lasting this long. I know it's been a long day, phenomenal sessions, great content, talking about the future of AI, the current of AI, maybe the past of AI a little bit. As you all know, I think cybersecurity has become this very, very hot topic in general. I have a test I call the airplane test. I've been working in cybersecurity now for about 20 years. And when I get in an airplane, inevitably somebody asks me, who's sitting next to me, what do you do for a living? And I say, I'm in cybersecurity. And for 17 of the past 20 years, when I said that, I was met with the following reaction. Like, nobody wanted to talk to me, okay? But what's funny is that in the last 3 years, when I say I'm in cybersecurity, all of a sudden people are like, what do you think about Apple versus the FBI? What do you think about the fact that the Russians might have hacked the DNC and so on and so forth? So it's pretty clear that cybersecurity has become this incredibly hot topic, incredibly relevant to our lives. And it's at the same time that AI has also become a very hot topic and incredibly relevant to our lives. And so today's panel and chat is going to focus on the intersection of these two areas. So the first half, I'm going to get the chance to interview Rehan, which is kind of neat because I work for Rehan at Elastica. And in that capacity, he asked me all the tough questions. Now I get to reverse the role here. So thank you for enabling me to do that. And then the second half, he's going to ask me about my perspective on the technical side of thinking about the intersection of AI and cybersecurity. So with that, Rehan, first of all, I want to ask you, can you just start maybe by educating the audience, what do you think of as the main broader applications? Why are we talking about AI and cybersecurity together? How do they fit?
Yeah, so I think if you look at security, other than if you take some main things out, like encryption or data manipulation or some high-level protocols that apply to security, which are very predictable, I think the foundational thing in security is actually data analysis. Whether you want to analyze a file to find out if it is malicious, whether you want to analyze an email to find out if it is, they're legit or not, or if you want to find if somebody's acting maliciously, these are all essentially data analysis problems and nothing else, and that's where the most intellectual property exists, the hardest part of it. And this is not like a normal data analysis. This is somebody who's trying to actually covertly trying to do things which you should not be able to find easily. These are very smart people who are applying, the best of the brains out there around the world, who's trying to basically covertly put these things. And now you apply data analysis to find these things. So of course, this has happened for a long time. Now there's an opportunity here to, not just apply normal deterministic methods, but go and apply more self-learning kind of method. And now pretty interesting techniques are being applied on various aspects.
Yeah, no, I mean, given that we have an MIT audience who's very interested in the technology and some of those techniques, can you double click on some of those different areas and talk about where you think those areas apply more effectively and what you think of some of the key application areas are in more detail?
Absolutely. So I think we all humans kind of relate to it when it ties to us. So let's think of a user. I'm a user, let's start with first thing, I have few devices. Now those devices, I need to make sure there is nothing malicious on those devices, which means the files sitting in there, they are not doing some damage to those devices or not sending some data out, right? Which means you have to apply either some kind of a static analysis on the files, which is again a data analysis problem, and there are a bunch of different techniques that you can apply, or sometimes looking at the files statically, you cannot tell, because the behavior of the file is going to tell you once you start executing the file. So where you just execute those files and start looking at how is the machine behaving, what are different processes behaving, how is it actually going and talking to my file server, and from there you can actually tell whether it's actually malicious or not. So from a user perspective, first, are my devices have any issue? That's the first check mark. Secondly, if a user on a device these days is not going to be enough, he is, let's say, going to go to the internet. Now, internet is comprised of billions and billions of websites. By mistake or by somebody's malicious intent, the user may land on a website which actually has malicious content in it, which is going to still come and try to basically take over your session. There, you have to analyze, like, is the website, as something malicious? Now, how do you do that when there is millions of websites popping up every couple of weeks? So you have to go crawl the websites and you actually categorize them and you tell them if there's something malicious or rate them. That's another whole new area of how you actually rate different URLs and different websites. Now, this is the user going out, but data can come to the user. How? We receive emails. We receive file sharing links on Dropbox and other things, right? So now in that problem, you have to analyze every mail to understand if it's not a spear phishing attack, or where somebody's not trying to fool you to, for instance, log into your bank account and steal your password and then log in and do something with it. Or if it is not a file that if you click on it and it gets installed and it damages it may be a crypto locker kind of a file where it takes over your machine. So that's the third thing in which you have to dynamically apply data analysis and say, don't touch this email, or this should go to a junk folder. Then from the perspective, everyone is tied to a network. You don't go to internet without a network. So how you actually look at the network traffic to understand if something malicious is going on. Now, if you're an organization, when user doesn't own the content, organization owns the content, it is extremely important, because organization owns that intellectual property, that when the data is being sent out by a user, you know that if it's something wrong has been sent out. Wrong means very sensitive data has been sent out, which means on the fly, you have to open the file, classify it, figure it out if it has some sensitive content. If an M&A is going on, or to find out if there's an M&A document going out, or if it's you have a financial call with analysts tomorrow, and all of a sudden these files are leaving a day in advance, maybe it's okay to send because you're sending to your banker. Maybe it's not okay to send because you're sending to a friend because he's going to buy stocks. So again, it's a data analysis problem. Now, from another perspective, if you look at if you're a company where you're getting all these signals, you're a large company with 50,000 employees, you're getting all these signals. How do you make a determination? You're a security team. Which signal I'm going to pick up on? Which signal is going to be important for me? What action should I take based on which signal? Yeah, I'm the SOC team. So prioritization of the signals and justification that you should take action on this signal is extremely important. Right there, the issue comes is that, because the weakest link is the user, which user is potentially the compromised user, malicious insider, is acting like somebody is going to steal information. How do you actually pick up on that? Is there actually another area which you have to double click on? And then it's all about now orchestration. So if something is going wrong, should a human go and take some incident response, take some action, versus when the cars are driving, why couldn't be like a self-driving security network? The orchestration happens on its own because you figured out these signals and you figured out your run book or playbook, and you just run that playbook and isolate the user or throw it to a second factor authentication or something. So the reason, of course, I went through this thing is for you to understand security is When you say cybersecurity seems like it's one monolithic thing, it's actually just not. It is very specialized, different vectors of attack that you actually have to deal with. And then the SOC teams, they have to look at all of that together. And that's why I think AI, or in general, I would say machine learning, has a very, very broad application here. And that's why you're seeing a lot of companies kind of talking about it.
Wow, yes. I mean, it's funny. So, a number of years ago, Rehan and I were doing Elastica together. And at that time, Rehan made a conscious decision to talk about machine learning on the front page of Elastica's website, which I thought was kind of a strange thing. I said, look, most customers probably won't care how we're doing it. They really want to find out what we're doing for them, what problem we're solving. But in retrospect, I think it was a brilliant move because a lot of folks nowadays really want to understand the how. So I got to ask you, what was it like, in those early days? So Rehan had me build the technology while he talked to investors to figure out how to get it funded. What was it like talking to investors back then, and how do you think that journey has evolved over time, and what do you think that's going to look like in the next couple of years?
Yeah, I think it's a great question. I think, as you remember, it was back in 2012 when AI wasn't of course, AI existed for a long time, but it wasn't like in the most fashionable thing to put it out there. Where we actually went out and we said, we called it data science powered, and then we started using the AI term. Literally, we trademarked it, which is, I don't know how we could get that trademark, which says data science powered. But it was actually from a customer. I do remember that from a customer perspective, it was a very important thing for them to understand why it is differentiated and how you're finding things that you're finding. And because in security, what you're going to see, because especially if it's not consumer security, it's an expert selling to another expert, trying to convince that you have better efficacy, are you actually going to find more issues, or you're going to help them basically cut short the time in response time. They need to understand why and how you're going to basically do that. And I think having the how part up in our message really helps, I think. Now, of course, what we're seeing is it's become like everyone talks about it, and it's hard to tell who's actually doing it or not. Right. So let me flip around. I mean, you're the CTO of one of the largest cybersecurity companies. Where do you and you're the expert in AI. You were doing it when, frankly, nobody actually talked about it at Symantec. Where do you think we're in the hype cycle?
Yeah, so first I think it's important to note there's definitely a hype cycle between AI and security for sure. I think there's two parts of that hype cycle. The first part of the hype cycle is the idea that it's new, right? People have been applying AI to cybersecurity problems for a long time, at least as far as a decade plus, where we've seen real production systems using machine learning techniques to protect actual customers. For example, I assume everybody here does online banking at some point. There's a good chance if you do online banking, there's a machine learning system on the back end that tries to identify fraud or fraudulent transactions. That's been around for a long time. In fact, I talked to one of our customers, and I know this pretty well because RSA builds some of that technology. And one of the major banks told me, you know what, we don't care if the password is correct or not when you type it in. The reason they don't care is because they assume that somebody else already knows your password when you type it in. What they do care about is every other aspect of the transaction. What time of day did you log in? Where did you log in from? What set of actions did you undertake when you did log in? And based on all those different characteristics, based on all the different signals or features, they can come up with a disposition to determine whether or not that transaction is likely to be fraudulent or not. Great example of machine learning used in production systems in a security context for a long time. So the first part of the hype cycle is the idea that it's new. The second part of the hype cycle, and I see this in a lot of startups, is making it seem like machine learning is like the cure for world peace or curing cancer or saving the whales and whatnot. Now, I mean, maybe after today you might think it can do those things, but I think in security there's still a ways to go. And I think there's an element here where we certainly see security, the needle may be being moved a little bit, but the real question is how much that needle can be moved. And there's a lot of hype around that, which I think can be difficult for your typical customer to understand because most of our customers today can't tell the difference between a good machine learning implementation and a bad one. Not because they're not interested, but just because they don't have the time and the bandwidth to make that determination. So there's definitely a lemons market out there in this intersection of cybersecurity and AI that we have to be very cognizant of and be very careful about.
I remember early days when you're building this stuff, you had this, let's not make these mistakes. These are the common mistakes that are made. Maybe it's good for you to share those, what are the common mistakes
Sure.
implementing these things people make?
Yes, I think the biggest mistake I see being made is that people forget that machine learning has to start with good data, right? It's very much garbage in, garbage out. A lot of engineers tend to get so focused on the classifier and the most technical aspects of an implementation, they'll sit there and they'll spend 6 months tweaking every parameter of their neural network and then ignoring the fact that their data has major fidelity issues. We're sitting here in California. You can't make good wine from bad grapes. Same thing applies in machine learning, especially applied to a cybersecurity context. The second element is beyond just focusing on data, there's also an important element of domain expertise. You start off with good data. The next thing you've got to be able to do is extract good features from that data, features that are relevant to the problem you're trying to solve. And that's where you need domain experts to help identify what those critical features can be. So for example, you talked about the idea of applying machine learning to look at network traffic to see if a particular domain name might be good or bad when somebody's visiting it. If you go inside of RSA Security Operations Center and you ask the front analyst, okay, what's the first thing you'd look at if you look at a domain name? They'll tell you the first thing I'm going to do is I'm going to do a whois lookup on the domain, find out how old the domain is. If it's a new domain, a bit more likely to be risky. If it's a domain that's been around for 6 years, a lot less likely to be risky. Probably the most important signal you can look at when you look at a domain name. Now, I don't care how advanced your deep learning techniques are, they're not going to figure out to look at whois when they look at a domain name. You need a domain expert to say, you know what, look at this particular feature. So the idea is you start off with really good data and focus on your data problem. You then identify good features. And then it almost doesn't matter what classifier you pick. They're going to perform within a percent, maybe a fraction of a percent of each other in real life. And in fact, you're better off in most situations picking a really, really basic classifier, because at some point, you may have somebody out there using this classifier in real life to make determinations, and they may not have a PhD in machine learning, or they may not understand maximum margin separation or anything like that. They've got to be able to make a determination on the spot with limited information. So I also want to one last thing since we've got a minute left. You know, I think the other challenge is that we're dealing in cybersecurity with a sentient adversary, somebody who can modify their techniques on the fly and adapt. That's an area that machine learning has struggled with. You know, there are areas like transfer learning and on other topics that are really focusing on how do you deal with the problem space changing. But I experienced this firsthand personally. After when I was at Symantec, I was trying to build a system for doing certificate reputation. So I had a bunch of data at Symantec on files and file reputation scores. And I thought, okay, we can apply some machine learning to this problem. I can apply a graphical model. And since most files are digitally signed, I can figure out whether or not a given digital certificate, by the way, technology that was pioneered at MIT, could be used to determine whether or not a file was good or bad. So I tried to apply this approach in practice. I had a bunch of data. I was trying to come up with a spreadsheet that would help me understand this stuff. And I remember, you know, at one point, I found that there were more or less kind of two sets of certificates. Certificates associated with very, very well-known vendors, you know, Microsoft, Adobe, and so on. These things were all digitally signed files. All those files were very popular, easy to tell that they were good certificates. The other half of my data had a bunch of bad certificates, things that you could tell were pretty clearly wrong. They were only being signed or being used to sign files that were very, very infrequent in nature, very low reputation files. But I had this one line on my spreadsheet, and I vividly remember line 23. And on line 23 of my spreadsheet was this one certificate which defied every aspect of my model. And so at that time, I looked at it. I couldn't figure it out. I thought maybe there's some data fidelity issue. I kind of gave up, went on to do a startup, and then forgot about everything that I was working on. And 6 months later, I was reading about a new threat that was introduced called Stuxnet. Now, Stuxnet was the first military-grade cyber weapon. It was being used to attack the Iran nuclear power facility, and it was extremely sophisticated, unlike anything we'd ever seen. Stuxnet was digitally signed. It was digitally signed by the Realtek system certificate, a legitimate certificate, which was line 23 of my spreadsheet. I bring this up because here I was, staring at the first military-grade cyber weapon in the world before anybody probably knew it existed other than some of the secret agencies, so to speak. I had malware background, I had a security background, and I couldn't pick it out. It was hidden in plain sight. I think it goes to show that the problem we're dealing with when it comes to applying cybersecurity in general and applying machine learning to cybersecurity in particular is very, very tricky, and we're dealing with really complex adversaries. I believe we can move the needle fundamentally, but I believe we have to be very, very careful about overhyping how far that needle can move. So with that, I think we're out of time, and I want to thank everybody and hope that story was illuminating. And Rehan, thank you so much for the time today.
Thank you so much.